get together, that's this little ellipse, that's called the concordance area. If you go down here, you get this number. Oh, handy whiteboard. Remember I said it's 27% dark matter plus 5% us, 32. And that's what we get. If you look at the data, so 30 is right there. So we're right in that neighborhood. And everybody agrees that 70%, roughly, 70% of the universe is dark energy. So, I said this a few minutes ago, we would like to have science that's completely independent and see if they get the same numbers. So the supernova guys get this big blob, cosmic microwave gets this. This is called baryon acoustic oscillation. It's the sound waves. Next time I'm going to tell you about what that really means. And see how much. Yeah. So this is the same kind of thing. Here's the amount of the fraction of the universe that is matter of all kinds. The sum of dark matter and us, and it's like right there, 0.3. Oh, and this is where we get the Hubble constant too. The reason this curve is here. This data tells us the Hubble constant is 68. I have 69 up there. So that's one way to get the Hubble constant. So let's go on for a couple more minutes. Baryon acoustic oscillations. Here's the thing. When we were looking at the let me get back to this. These bumps, the spacing of these bumps tell us about the acoustics. When the universe became transparent, the acoustics stopped. Because for sound to propagate, you have to touch something, or you have to have air to convey the sound. When the universe becomes transparent, there are no more sound waves. I mean, how does sound propagate if you have a hydrogen molecule or hydrogen atom here and another one over here, and this one, and somebody sends a sound wave, they're not in contact. How is their sound? Remember the movie Alien, one of my favorites? The caption of the movie was, in space no one can hear you scream. If you haven't seen Alien for a while, you should watch it. It's great. So, when the universe became transparent, it also got silent. So let's jump forward here. And a quiet universe, the distribution of matter that eventually would become galaxies is frozen now. There's no more sound to move things around. So we should be able to look at the distribution of galaxies that exist in the universe we see today and see how far apart those galaxies were, influenced by the time at which the universe became quiet. And we can see it. Here's data on the separation of galaxies and superclusters. You know, at some point, astronomers are not dealing with, they're certainly not dealing with stars. The smallest thing they deal with is galaxies, and then you have clusters of galaxies, like a couple million galaxies that are bound together. And you're coming down this curve, you're just seeing the size of space. And then this bump right there is exactly where we expect it to be. This is the result of looking in the right place from the data that's in the cosmic microwave background. So when we see this thing called BAO, come on. Where'd that thing go? I passed it. I'm trying to go too fast. Concordance. Right there. Thank you. So this big green bar, this tells us how much matter is of dark matter plus us is in the universe. It has nothing to say about how much dark energy is in the universe. This is completely ambiguous about dark energy, but where everything intersects, we have concordance. Let's wait for this because I have to clear the room for the next class. But, so, are we okay? You guys are going to be able to download lectures. If you look online, you should see videos on follow the link to my YouTube page. And I'll probably have to do a little amending on today's lecture because I don't think the camera was working at first, but I hope it's working now. Any last questions that we can answer in our next session? You can always write to me, and I will, just like I did for you, we'll announce your question and we can talk about it as a group. Yes, sir?
I just came across, you mentioned a book written a while ago, 2005, by Green.
Yes?
He gave us a series of PBS shows.
Right.
They're a little out of date, but they're not bad.
Yes, yes. That's,
And you can get them for something.
they're on YouTube.
Yeah, the whole thing.
Look around. Yeah, so that's Green with an E at the end. If you're going to read his books, don't read the first one first. The second one's really good. Okay? Thanks for sticking with me. I know I got started late, but it was a crazy time with the phone calls. Okay. Oh, yeah, she didn't come because I had to be here. She said, be here at 8 a.m. So, but you should call her about this adventure we're going to take. Oh, that's crazy. And I have to admit, when I first read the message, there's no way. An hour later.
Last year, I didn't even need to. Right.
The total energy in the universe. Right, because we have to take into account E equals mc squared. That's the energy of the matter. And then there's light, and then there's these strange other things. So it's the total energy divided up into a pie chart. Yes, sir. Okay, yes.
This time I got hung up with my doctor, not my vet.
You come when you can, read the notes, and I hope they work for you.
Flunk them.
Yeah, right, you're getting a low grade.
Thank you so much.
Okay.